Good morning, everyone. Our project focuses on the application of differentiation in profit optimization for business decision making. Differentiation is a mathematical process used to measure the rate of change of a function. It helps determine how one variable changes when another variable changes. In business, differentiation is commonly applied to analyze revenue, cost, and profit in order to identify the most beneficial business decisions. We selected this topic because profit optimization is an important objective for businesses. By applying differentiation together with digital tools such as Microsoft Excel and Desmos, businesses can determine the optimal production level that maximizes profit more efficiently. The main mathematical concept used in this project is the profit function. In business, profit is calculated by subtracting cost from revenue. The relationship can be represented as Px equal to Rx minus Cx, where Px represent profit, Rx represent revenue, Cx represent cost, and X represent the number of units produced. This profit function serves as the foundation for our optimization model and allow us to determine the production level that generate the highest profit. For demonstration purpose, a simplified business model was used in this project. The revenue function is Rx equals 120x, while the cost function is x squared plus 20x plus 100. By subtracting the cost function from the revenue function, we obtain that profit function Px equals negative x squared plus 100x minus 100. This profit function is then used to determine the production quantity that maximizes profit. To maximize profit, the profit function was differentiated to obtain the first derivative, p prime of x equals negative 2x plus 100. By setting the first derivative equal to 0, the critical point was found at x equal 50. The second derivative test was then applied. Since p double prime of x equals negative 2, which is less than 0, the function reached a maximum profit point. Therefore, the optimal production quantity is 50 units. Differentiation plays an important role in business decision making. By applying differentiation, businesses can optimize profit and make more data-driven decisions. As a result, organizations can improve profitability and enhance overall business performance. In practice, differentiation is commonly used in production planning, cost management, pricing decisions, and resource allocation.
Moving on next, we would like to demonstrate two methods to display the profit maximization using differentiation, which is Microsoft Excel and Desmos graphing. First of all, for Microsoft Excel, we will need to create a table that has columns including units, revenue, cost, and profit. And first of all, we will insert the units ranging from 20 to 70. After inserting the units produced, we will also insert the units of each column using their respective formula for the revenue, cost, and profit, as displayed in the tables below here. After we have completed the table, we will use the graph function in Excel to create a line graph that consists of units produced and the profit, whereas the highlighted point is the maximum point that will produce maximum profit. First of all, we will look at the revenue column and we will insert the revenue formula, subsequently followed by the other revenue costs at different units. Secondly, we move on to the cost column, which we insert the cost formula and subsequently accordingly to the units produced. Lastly, profit column, which we use the profit formula and insert respectively according to units produced. And according to the graph here, at the point it reaches maximum profit, it will be highlighted, and that indicates the profit maximization in the line graph. For the next method, which is Desmos graphing, first of all, we will insert the profit formula into the function. And once the formula is being inserted, Desmos will create a graph according to the formula. And in this formula, since it indicates the profit graph is being produced accordingly to the units produced. And once it hits the maximum profit, it will display a curve that is frowning. So at the point of 50 units sold, that is the maximum profit, which is 2,400. First of all, we will insert the profit formula negative x squared plus 100x minus 100, and afterwards the graph is being generated in the Desmos, but we need to do a little bit of pinching because the scale might be too large to display in one screen. So we will do some pinching and a little bit more, and yep, that indicates the profit maximization graph. And at the point of 50 units sold, it will generate a maximized profit, which is 2,400. First of all, we will insert the profit formula.
Through this project, we learned that differentiation is not only a theoretical mathematical concept, but also a practical tool for business decision making. By integrating mathematics with digital tools such as Microsoft Excel and Desmos, businesses can analyze data more efficiently and identify optimal solutions. In conclusion, the maximum profit of 2,400 ringgit is achieved when 50 units are produced and sold. This project demonstrated how mathematics and technology work together to support better business decisions. That's all from us. Thank you.